Hey, what's up, game designers? So right now we have this character and he can walk around and do things, but notice that he goes out of frame. The camera's not following him. I'll show you a really quick, easy way to do it, and then I'll show you a better way to do it, and you can kind of decide which way, but I'll give you the code and try to walk through it with you. So let's go ahead and do that. I'll exit out of play mode. The easiest, quickest way I can do this is all I have to do is take the main camera here and drag it down. Well, first I'll move it up to where he's at. So I'll take this right here, click this button, and then I can move the camera kind of to follow him or put him in frame. And then I just drag the camera right there onto the Trogdor player. I hit save, I'll press play, and watch what happens now. See, now the camera follows him. Super easy, and problem solved. However, this doesn't really look great. There's a more artistic way to do it. So I'm going to walk you through that code. I recommend following the code because it'll definitely make your game look more pro. Okay, so let's go ahead and do that code. I'll undo what I did there and leave the main camera there. We're actually going to add a script to it. So with that main camera selected, you'll add component, new script, and we'll go ahead and call this camera follow. Perfect. I'll hit create and add, and it's going to be in my assets folder. Just to keep things managed, I'm going to go ahead and drag it into the scripts folder. Perfect. Now I will double click that and let's edit it in MonoDevelop. Okay, so here we are in MonoDevelop. We've got our boilerplate code. So let's add some variables here in this public class. Okay, so let's go ahead and go public transform target. And as you remember, the public means that this variable will be available to us in the Unity inspector panel. I'm going to make a note right here because sometimes code can get confusing and I'd like to make things more clear for you. So I'll just go ahead and say what this target is going to be our character. So target is our character, our player, right? And then let's make one more, public float smoothing. So we know that this is actually going to be a number, 5f. So when I make a number that's a float, I need to put an f there for float. So public float smoothing. We're going to be using that, a variable down here, in just a second. Okay, so one more variable up here. It's going to be a vector3, and we're going to call it offset. So now let's assign offset a value here in the start function. Offset is equal to transform.position minus target.position. So let's go into update. Now we're not gonna call it every single frame. We're actually gonna call it fixed update. Okay? So I don't want you to think that's called once per frame because it won't be. We want to get rid of that. And then we're gonna create a vector3 target cam position is equal to target.position plus offset. Okay, so game character position plus that offset that we've created right here, and we gave it this value right here. So I can see that some of you might be getting confused how we're jumping around with these variables, but trust me, it works and it's going to make sense. So now we're going to use something called a vector3 lerp. And all a lerp is an interpolation between two vector3s. So I'm going to make a note before we actually write that code out so you can kind of remember. So a lerp is basically a linear interpolation between two vector3s. And it looks like this. Vector3a, vector3b. These are the two vector3s that you'll be interpolating between, and then a float value. Okay, that's what it's actually going to look like. So now let's write out that code, and it'll start to make sense. So transform dot position is equal to vector3 dot lerp. That's that lerp we talked about, and the first vector3 will be transform dot position, and the second vector3 will be target cam position. And then the float value will be smoothing, which is this variable up here, 5 float times time dot delta time. Now that sounds crazy confusing probably to some of you. So let's define out what delta time is, because you know what all this other stuff is, right? So delta time, time dot delta time, is actually the time in seconds it took to complete the last frame. Now, for these games and these computers, it's going to be way faster than a second to complete a frame. You're usually getting way higher frame rates than that, especially on a simple game like this. And the reason we use that time.delta time is so that we can make games frame rate independent. Okay, so this still may be confusing, but I'm trying to simplify. This code can look really intimidating for a first-time coder, but when you start to think through it, and you'll have to do this, you'll have to spend some time in code thinking, what is this? What's that? What are all these different variables doing? And when did we assign them? And why did we assign one over here, and then we call it over here, or whatever? So we know this is our character right here. We know this is just a value that we're using for smoothing, and we could change this value. And you could see what would happen if we change it dramatically. And then this is, we're not giving this a value yet. We're just creating a vector3 and naming it offset, right? And then we're assigning its value right here. Offset is equal to transform.position minus target position. We get target position right here because transforms have a position on them. So we named our transform target, and then we are accessing its position, right? And then transform position. Okay, so, and this confused me for a while. I have this transform position here, and I'm like, we didn't declare this explicitly. We didn't ever create. So on all these other variables, we're creating them somewhere. We're creating offset right here, and then assigning it its value here. We're creating smoothing right here and assigning its value. We're creating target right here, and we're going to assign its value in the Unity editor. In a second, we'll drag and drop our character onto this public variable. But this confused me. Where is this transform position coming from? And some of you guys that are tracking with me are still probably like, yeah, where is this transform position coming from? So I went into the Unity manual, and I highly recommend going there. If you're going to continue encoding, here, I'll just pull it up for you. I have this transform.position. I can search all kinds of things in scripting, and that's how I learn about, you know, the different, because there's a ton of stuff in here. Right? You can't memorize all of it. It's kind of like, you know, when you're learning HTML, CSS, and JavaScript. There's a ton of stuff in there. It's hard to memorize it all, right? Even for the teacher. So I had to look this up, and what this is it's already public, which means we already have access to it automatically. So see, in this example code they wrote here, they never actually, they just assigned it a value. They didn't declare it like for other variables, right? So this is one that's the position of the transform in world space, and it's public. It's already available to us, so you don't have to worry about that one. You can just write it in here, and that's how we were able to assign its value down here without ever having to create it somewhere. So let's actually test this out and see if it works. So I'm going to save this, and let's go into Unity. And what we have to do now is click on the camera, and we actually have to assign the target a value. And remember, the target is the character. So I'm just going to grab Trogdor player and drag him right there, okay? Now, when we save and run this, we should have a much better camera follow that you guys can use for your games. And so now you can see it's a lot smoother camera, okay? So there you go. Hope you enjoyed that, and I'll see you in the next one.